Hey everyone. So in this video, I'm going to just do a quick intro and a couple examples for graphing tangent and cotangent. And so what you can see here is I've got kind of our parent function, y equals tangent of x, y equals cotangent of x. And below it, I've got a little bit of a unit circle, and there's a reason I've picked this section of it, but we'll get to that in a little bit. But I just want to kind of remember, fill in our values. So tangent of 0, like if I'm at 0 here, that would be y over x. The y value is 0, x is 1. So this is 0, and if you remember, we kind of built up from there, root 3 over 3, and then tangent of pi over 4 was 1, and then it was root 3, and then it was undefined. And if we went the other way, we'd have negative root 3 over 3, negative 1, negative root 3, and undefined. And so what we kind of see from this picture is that at pi over 2 and at, I'm going to call it negative pi over 2, we have undefined for tangent, which means we're going to have asymptotes there. So our parent function of tangent is going to look something like this when we graph it. Okay, we're going to make tick marks at negative pi over 2 and positive pi over 2. And those will be our asymptotes. Okay, at 0, I know my function is 0. And because I'm, faced with the choice of root 3 over 3, 1, or root 3, if I want to mark one of those points, I kind of like the idea of marking the one that's 1. So when I get to pi over 4, conveniently that's halfway between there, and negative pi over 4, I know my y values are 1 and negative 1, so I get pi over 4 comma 1 and negative pi over 4 negative 1. And as we get closer and closer to that asymptote, I know it's going to go up the asymptote up to infinity, because that tangent value is going to get bigger and bigger and bigger. So my tangent graph, you might remember, looks something like this. And then because this is periodic, like if we drew another period, it would go up like that, and etc. It would keep repeating over and over again. We're going to stick with one period, just like we've been doing with the others. Okay, so that's our basic tangent graph. Our domain, well, an asymptote shows up at pi over 2, so we would say all reals x can't be pi over 2 plus, and then that asymptote is happening every pi, so pi k. And in that case, for a tangent, the period is actually pi. This function is going to repeat over and over again every pi instead of every 2 pi. So range, negative infinity to infinity. We could kind of go through the same process with cotangent. Our values for cotangent starts at undefined, because now I'm looking at x over y, 1 over 0, undefined, and then it's root 3, 1, root 3 over 3, 0, and if we go back on the other side, we just do it in reverse, negative root 3 over 3, negative 1, negative root 3, and then undefined again. So this time, notice that our asymptotes are at 0 and pi. So when I make my cotangent graph, I'm really actually going to focus more on that first and fourth quadrant. I've got 0, and then I've got pi, asymptote, sorry about that, and then halfway between, at pi over 2, that's where my graph is equal to 0, and then the 1 and the negative 1 happen at the pi over 4 and 3 pi over 4. So at pi over 4, we're at positive 1. So I get this point there, 0. 3 pi over 4, I'm at negative 1. And so the cotangent graph kind of is decreasing. Looks similar to tangent, but it's kind of mirror imaged and it's shifted over. All right, so those are our parent functions. Tomorrow in class, we'll do a couple examples, but the main idea here is we're going to be basically finding our window of where the left and right asymptote are. So after we shift and do any transformations, where's my new asymptotes? And then we create this graph in between. So we've got a center point, and we've got these two kind of vertical stretch points. That'll be how we create our graphs for tangent and cotangent. Okay, so that's all. Thanks for watching.